Ladies and gentlemen of geometry, we're looking at 9.2, talking about the surface area of prisms and cylinders. Surface area, exactly what it sounds like. Basically, you're trying to figure out the area of each side and the top and bottom. So the sides we call lateral areas, and the surface area is going to be just adding the top and bottom to that. So that's kind of what we're looking at. All right, so prisms look like this. So you've got a triangular prism because the base is a triangle. Rectangular prism because the base is a rectangle. A cube is every side is a perfect square. Pentagonal prism, please notice that the base is a pentagon. And hexagonal prism, same idea. The base is a hexagon. So, named for their base. Cube just means everything is the same side. Now, so a triangular prism, if I was going to draw a net, basically that means I've got two bases that are triangles. Then I've got three sides. So that's kind of what I'm looking at to do. So that would be what a triangular prism looks like. A rectangular prism, so you draw your two bases. So there's one side that connects those. So then you've got a short side that matches up, short side matches up, and then a long side that kind of becomes the top. For a cube, if you remember the previous notes, a cube has just got 6 congruent squares. All right, so that's what a cube looks like as drawing the net. So pentagonal prism, same kind of idea. You're going to draw your pentagons, hopefully much better than I do because I'm a terrible artist. So draw here. So then you've got each side that matches up, and you got to visualize kind of folding this all up and turning it into a prism. Hexagonal prism, same idea. So you draw your hexagon. Boom, boom. Then keep going, and then there should be 6 of these. So there's your hexagonal prism. So now take a look. We've got terms right and oblique. Please notice right is straight up and down. Oblique is leaning. Okay, so the base is going to be kind of what you're naming this by. So it's going to be the basically your base shape. Okay, a lateral face is basically going to be this side shape. The lateral edge is going to be just that. It's going to be a line. So this would be considered a lateral edge. A base edge would be this. Altitude would be the height from top to bottom in parallel. So it'd be or perpendicular. So this could be considered the height straight up and down. On this one, this would be considered the height straight up and down. And a cross section would be if I was going to cut this thing right in half, what would it look like? All right, so lateral area. Lateral area basically means area of all lateral sides. So, no basis. No basis. Okay, so you're taking the area here, area here, area here. You've got a triangular prism. So that's going to be the area of this, this, and this. That would be lateral area of a prism. So it's going to be the area of all lateral sides. So basically everything except the base. Oops, don't need that. Okay, so let's take a look here. What type of prism is this? Well, this is going to be to be most specific, this is going to be a right triangular prism. How many vertices does he have? Vertices just means points. So 1, 2, 3, 4, 5, 6. So 6 points. How many faces? Well, how many two-dimensional sides? So 1, 2, 3, 4, 5. How many lateral faces? 3. How many edges? 1, 2, 3, 4, 5, 6, 7, 8. Draw a shape of the cross-section parallel to the bases. So cross-section would basically be if I sliced right through this, what shape would I make? And that is a right triangle. A lot of times, this would be a similar to the base. So figuring out the lateral area is I'm going to have 3 sides. Okay, so I'm going to have Ooh, you know what I got to do? I got to figure out how long that is. So I've got a right triangle where this is 5, this is 6. So that's going to be 25 plus 36. Take the square root of that. So this is going to be about 7.8. So kind of the short way to figure out the lateral area is to take the perimeter of the base times the height. So I'm going to take 5 plus 6 plus 7.8. I'm going to multiply that times 7. So 131.672. So another way to think about this is if I draw each side, so I've got the back side, which is 5 by 7. I've got the bottom, which is 6 by 7. Then I've got this hypotenuse face, which is 7 by 7.81. So I figure out the area of this, figure out the area of this, figure out the area of this, and add all those together. That's going to get me that. So, talking about prisms and cylinders now. So now we've talked about prisms. We're going to keep going into cylinders. Cylinders, or a prism looks like this. So this is going to be a hexagonal prism. So how many vertices does it have? So basically how many points does it have? It's going to go, so you got 6 here, 6 there, so it's going to be 12. So how many lateral faces? So how many sides does one base have? So that's going to be 6. How many edges? So 1, 2, 3. How many lines basically? 6, and then 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18. What shape is the cross section? Well, it's going to be a hexagon. It's actually technically going to be a right hexagonal prism. Find the lateral area. So again, you're going to take 5, 5, 5, 5, 5. Okay, so you're going to take 5 6 times. Times 12. So that's going to be 30 times 12. So that's going to be 360 centimeters squared. That's going to be my lateral area. So surface area of a prism is basically your lateral area plus the area of the base. So you take twice the area of the base. Okay, remember lateral area just means the perimeter of your base times the height. So now you're just going to add the two bases. Okay, so figure out the area of the base, whatever shape that is, and then multiply by 2, add it to this. So, figuring out the surface area, so let's take a look. Let's call this my base. Okay, so the perimeter of the base is going to be 20. Okay, so my height is 9. So lateral area is going to be 20 times 9, which is going to be 180, plus twice the area of the base. Now the area of the base is easy here. It's 6 times 4. So that's going to be 24. So the area of the base is going to be, two bases is going to be 48. So I'm going to add those two, and I'm basically going to get 228 feet squared. There's my answer. All right, so I figured out the lateral area, added the two bases, because there's this side and this side, and put those together. So find the surface area of the triangular prism. So once again, this is going to be a right triangular prism. So that's going to go 12, 12, 12. So this is going to be 12. So this length is going to be 16.97. So lateral area, let's change gears here. Lateral area, so perimeter of the base is going to be 40.97 times the height of 8. So that's 327.76. And then the area of the base is going to be 12 times 12 divided by 2. Base times height divided by 2. All right, so that's going to be 72 is the area of one base. So now I'm going to multiply it by 2 to get 144. So I'm going to multiply those two together, or sorry, add those two together, plus 144. And my answer is going to be 471.765 millimeters squared. There it is. All right, surface area here, once again, not too tough. 6, 6, 6, and 4 lateral area. Perimeter is going to be 24, perimeter of the base. So all the way around. I'm going to multiply that by 12. And so my lateral area is going to be 288. The area of one base is going to be 36. So times 2 is going to be 72. So I'm going to add 72 there. So my total surface area is going to be 360 centimeters squared. Okay, that's all I've got for surface area of a prism. Come talk to me with questions, and if it helps, you can draw a net every single time. That will kind of help you break things down.